Hey everybody, Miss Negron here. So we're going to be talking about the area of a sector and sector length to kind of wrap up our circles unit. But before we do that, I would like to spiral back a little bit to include central and inscribed angles. So if we take a look at the do now, it states, in circle M below, diameter AC, chords AB and BC, and radius MB are drawn. Which statement is not true? So because we're looking for which statement is not true, we want to go through each answer choice to figure out which one is true to get to our answer. So choice number 1 states that ABC is a right triangle. Well, if you look at your diagram, angle ABC is inscribed for a semicircle. So because it's inscribed for a semicircle, I know that because I have the diameter of AC, I know for a fact that if the diameter is AC, that the arc here is 180 degrees. And because our angle is inscribed, half of that is 90. So angle ABC is actually a 90-degree angle, making choice 1 a true statement. Therefore, it is not our answer. If we look at choice 2, ABM is isosceles. So if we look at our triangle here, AM and BM are both radii. So because both of these segments are radii, I know that they are congruent because all radius are congruent. So therefore, ABM is actually an isosceles triangle. So because that's a true statement, choice 2 is out. Now if we look at choice 3, so we have the measure of arc BC. So BC is this arc here. That is equal to the measure of the angle BMC. I know that this is also a true statement because BMC is a central angle. And the central angle is exactly equal to the measure of the arc. So choice 3 is also a true statement. So therefore, by process of elimination, it should be choice 4, but let's check it out anyways. So the measure of arc AB is equal to the measure of angle ACB. Well, if we look at ACB, this angle is actually an inscribed angle. So because the angle is inscribed, I know that this has to equal to half of my arc. So arc is going to equal 2 times the inscribed angle. If we're working backwards, half the arc is equal to the inscribed angle. Therefore, choice 4 is our solution. Now let's move on to the mini lesson regarding arc length and the area of a sector. So in regards to arc length is exactly what it sounds like. It is the length of the arc. So you want to figure out how long it is. Well, in circles, we're going to be using a variable called theta, which is a Greek letter, and that is used to represent an unknown angle. Because we're looking for the outside of the circle, circumference is going to come into play here. So I put the circumference formula, which is equal to 2 pi r. Remember, pi is a number. R in this case would be your variable to represent your radius. And then that together, when you multiply, it gets multiplied by 2 in order to find the circumference. When we're looking at arc length, there's 2 formulas that we can use. So we can either use the first formula, where your arc length is represented by S, and then your theta actually represents your angle, but in radians. Radians is a little bit different than degrees, which we will get into in another video. So for today's purposes, we're going to be using the second formula, where our arc length is equal to theta, where theta is in degrees, divided by 360 to represent part of our circle, and then multiplied by the circumference, okay? So for the first example here, it says compute the arc length of UV based on the diagram below. Well, based on the diagram, I can clearly see that my theta, my central angle, is equal to 70 degrees, and then I know that my radius is equal to 8 inches. So based on this, I can go straight into finding the arc length. So I'm going to use the formula S equals theta divided by 360 and then multiplied by my circumference, which is 2 pi r. So once again, theta in this case will be in terms of degrees because you're looking for this arc right here. So therefore, theta will be 70 divided by 360 times 2 pi, and then the radius here is 8. So now when you simplify this, the regions may or may not ask you to leave it in terms of pi. So if you were to leave this in terms of pi, you would do 70 divided by 360 multiplied by 2 times 8. So overall, that would give you roughly 3.1 repeating, and then keep the pi with it. So that's in terms of pi. If they say to round, then they want you to multiply the pi throughout. So this is roughly 9.77, and keep our units for inches. So for the arc length, it's going to be 9.77 inches, not in terms of pi. Okay, so remember, that is when pi is being multiplied out. Now let's look for the area of a sector. So instead of just finding the actual arc length, you want to look for this entire area here. Okay, so everything that's in orange is what we're going to look for. So in this case, we're going to take the combination of area instead of circumference and then still multiply it by our degree measure divided by 360. Okay, so it says compute the area of the sector created by arc VTU based on the diagram below. So we're going to keep our area, so A equals, because we're dealing with a segment here, a specific sector here, we're going to take our theta, divide it by 360, and then multiply it by the area of a circle, which is pi r squared. Theta is still 70 degrees here, so it's going to be 70 divided by 360 times pi. Radius in this case is 8 still, and then square that. Okay, so remember, if you're talking about in terms of pi, you do not want to multiply out the pi. So if you do 70 divided by 360 times 8 squared, that's going to give you 12.4 repeating, and then keep your pi. If they want you to multiply it out, this would be roughly or about 39 inches once everything gets multiplied out. Okay, so that is how you find the area of a sector and arc length in a circle.